right, chapter or 7th grade, this is chapter 8.2. We're going to talk about rates. And rates and ratios are kind of related. They're just a little bit different. A rate is still a fraction, but it's a little different. We're on page 404, by the way. A rate is a ratio in two quantities measured in different units. And I'm copying this from the book. If you can't read, I know my writing is terrible with this pen. On page 404, you can see rate as highlighted. It's just below the box where the hand where they're doing the heartbeat little experiment thing. An example of a rate that you're very familiar with would be this right here. Going down the road, speed limit. And it says that is a rate because it's 65 miles per hour. Anytime you see per, that's a fraction. So 65 miles per hour in 1 hour. So notice there's two quantities and they have different units, miles and hours. So you guys see them all the time, you just don't realize it. A unit rate is a rate with a denominator of 1. And actually right there, that's a unit rate right there, 65 miles in 1 hour. If I said to you, what is the unit rate if you go 100 miles in 2 hours? You would have to make this have a 1 on the bottom. So you would divide by 2, and it would be 50 miles in 1 hour. So, I don't know, probably not by car because not many people travel 50 miles an hour in a car, the speed limit. So, anyway, that's it. Let's do some stuff with that. Kudzu? I don't know what that is. It says during peak growing season, the kudzu vine can grow 6 inches in 12 hours. So right away when I see that, I see 6 inches in 12 hours. So I'm going to write that as a ratio. Actually, it's a rate, not a ratio. It's a rate because I have inches and hours. What is the peak growth rate in inches per hour? So basically what they want us to do, inches per hour, is they want us to take that and they want us to write it as a unit rate. They want us to get 1 on the bottom for 1 hour right here. So how do I make 12 become a 1? I divide it by 12. And I take 6 divided by 12, and that would be 0.5. So that, in an hour, that would grow 0.5, half an inch. Wow, it can grow 6 inches in 12 hours. That's like pretty much could grow in front of your eyes. You could sit there and watch it. That'd be pretty cool. So here's their solution. Same thing we did. There's the answer. Okay, speed skating. A speed skater took 2 minutes, 30 seconds to complete a 1,500-meter race. What is the skater's average speed? Notice they have it in seconds, so what I need to do is I need to change 2 minutes, 30 seconds to seconds. This is 2 60s, which would be 120 plus 30 for 150. So the skater can go, what is the skater's average speed? Speed is usually distance, so 1,500 meters in 150 seconds. Take that 0 off, that 0 off. 15, get this to be a 1. Divide by 15, so 10 meters per second. Wow, that's 10 of those meter sticks. 10 meters per second. So I say it's C. Let's see because B and C it's kind of confusing. I think you usually do distance. Yeah, see they have meters on the top and seconds on the bottom. 10 meters, so it's C. Yep, good. Okay, example 3. The store sells the same pasta the following 2 ways. 10 pounds of bulk pasta for $15 and 2 pounds of packaged pasta for $3.98. To determine which is the better buy, find the unit price for both types. And by the way, next time you're at the store, I noticed it at Walmart, if you look at the tags, the price tags that are on the shelves, and I think it's kind of in orange or in yellow up in the corner, it has the unit price, which means like, you know, like cereal, a lot of times it might be in ounces. Pop cans, soda, it might be by the can. You know, toilet paper, it might be per roll. It's just kind of a neat way to compare prices to see which is the better deal. So let's write, we get 10 pounds of pasta for $15, and we get 2 pounds of pasta for $3.98. I don't know if we probably should do the cost per pound, so we probably should write that this way. $15 for 10 pounds. How much would it be for 1 pound? Let's compare it that way. 2 pounds. So to get this to be a 1, we divide it by 10 to get a 1. So we divide this by 10, which would move it back. So it would be $1.50 a pound. This we divide by 2 to get a 1 on the bottom. Divide by 2, so $3.98 divided by 2, that's 1. 19, that goes in there 9 times, which is 18. $1.99 a pound. So it would be, to determine which is the better buy, so the better buy is to buy the bigger one. But if you know that all you need, you know, if you're not ever going to use it, then it would go to waste. That wouldn't be a good buy. So you have to decide there. So let's see which way they did it. There we go. Yep. Per pound. How much is it per pound? Yep, we did it. All right, so let's do some guided practice. You bike 68 miles in 4 days. Find the unit rate. So let's write the rate. You go 68 miles in 4 days. So how much did you do every day? What did you do in 1 day? Divide by 4. Divide by 4. Goes in there once. 17 miles a day. Whoosh, I get tired just thinking about that. Average speed, it takes you 1 minute, 40 seconds to walk 550 feet. What's your average speed? So 55 feet in, let's see, 60 in 100 seconds. So how much is it for 1 second? We would divide by 100. Decimal back, 5.55 feet per second. 5.5. I must have rounded it. Which of the following is a better buy? 2 batteries for $1.50. So that's $1.50 for 2. Or $4.80 for 6. Divide by 2. That would be 75 cents a battery. That would be 80 cents a battery. Just divide them out. This one would be a better buy. All right, that's it. Have fun doing rates and unit rates, and we will see you next time.